Good afternoon, ladies and gentlemen here in Japan. Good morning to Europe. I would like to welcome you all at the webinar on the topic of the artificial intelligence in Central Europe and Japan. My name is Stanislav Beneš. I am a commercial counselor of the Czech Republic in Tokyo, and I will be your moderator today. Together with me is here in our improvised studio, Mr. Richard Schneider, the director of the Czech Invest Office in Japan, who will be the main producer of this webinar. As the Czech Republic currently holds the rotating presidency of the Visegrad Group, we have the pleasure to host this traditional event, which is taking place in the online form this year. We have excellent lineup of presenters and the program is very rich. And so we certainly hope that you will find the webinar interesting. Before we proceed with the agenda, I would like to point out the possibility for all of you to send the questions to our presenters during the event through the questions and answers system. We will then prepare them for the Q&A session, which will come at the very end of our program. And now, without further ado, I would like to give word to Prague, to the Deputy Minister of Foreign Affairs of the Czech Republic, Mr. Martin Tlapa, and to ask him to officially address us on behalf of the Visegrad Group presidency. Mr. Deputy Minister.
Thank you to Japan. Good morning from Europe, from Prague and from other countries. So let me first thank all who are behind this project. It's a very innovative and very good way how to communicate in difficult time. And this webinar is very important even. And it's putting us not only one country, but the whole Visegrad Group. So I think it's a great initiative, and I would like to thank all who are participating in this project in all countries and all presentations. So thank you very much for that. It's not surprise that Visegrad countries are focusing on Japan because we have very live relations from the beginning of the transformation of Czech Republic. Japan was very active. It was and still is one of the largest investor to the Czech Republic, and I think that the same is true for all other Visegrad countries. At the same time, Visegrad countries are very active in boosting the economic growth and to modernize the economy, and also to use artificial development and artificial intelligence as one of the tools how to be successful in the global world in the future. So I think that this topic is perfectly coming together. And I think that the base of the experience we have bilaterally with the relations and the cooperation between Japan and the Visegrad countries in many sectors, including electronics, by the way, optics or car industry or high-tech industries. I think that there is a place for sharing the knowledge we can do together. That's why I'm very happy that we pick up during our presidency this event as one of the leading activities in our relations. So that's a very perfect way. And based on that, we have a discussion about how the world will change or not change after this coronavirus crisis we are facing now globally. And I think that one of the lessons we will learn is definitely think how artificial intelligence can help in medical industry, in health system in several countries. And the technology is definitely, I'm sure, will be demanded globally. So I hope that this event can put together the ideas, what we can do together based on our great relations, and also considering what is demanded in the world. So I think that the message is let's put our researchers together, let's encourage common projects, institutions, and think that there is a global demand for the new technologies, and we can offer something which is really needed. So that's a very important thing. We have special relations to IT, and many Japanese know that the world robot was discovered created by Karel Čapek, writer, and is now widely used worldwide. But I think that the most important thing is just learn from the history, but do the things which are demanded for the future. And I'm very happy that artificial intelligence, the system, how can boost the growth and the wellness, the happiness in the world is one of the important tools. So thanks all who are behind that. And we will be very happy cooperate as Foreign Affairs Ministry of the Czech Republic for the project. Thank you and have a good day.
Thank you very much, Deputy Minister. And now it is my pleasure to ask Mr. Martin Tomčo, the Ambassador of the Czech Republic to Japan, for his welcoming remarks.
Ladies and gentlemen, let me welcome you also on behalf of the Czech Embassy in Tokyo. I would like to thank all the participants and all organizers of our webinar. In accordance with our tradition, we plan to hold a V4 seminar at our embassy. However, the pandemic made it impossible. I am happy that more than 300 people have registered to this online version. Today's webinar shows the importance of development of artificial intelligence for the Czech Republic and the V4 countries as well. The timing is accurate. Japan has cemented its status as a technological leader in areas as diverse as aeronautics and robotics. It's no surprise that Tokyo Summer Olympic Games are organized under the slogan Country for Tomorrow or Discover Tomorrow. Robots are emblematic of Japan's status as one of the world leaders in futuristic technology. The organizers count on the wide use of artificial intelligence during the Olympic Games. It's my pleasure to introduce our esteemed guest, Mr. Naokazu Takemoto, is Minister of State for Science and Technology Policy and Minister in charge of Information Technology Policy, and also Minister of State for Space Policy, the Intellectual Property Strategy and Cool Japan Strategy. According to the original plan, Mr. Takemoto was supposed to sit next to me. However, he needs to be somewhere else due to emergency issues. So we are going to broadcast his video message. Last but not least, thank you for your attention. I wish everyone a successful webinar.
Good afternoon, ladies and gentlemen. I am Naokazu Takemoto, Minister of State for Science and Technology Policy of Japan. I'd like to express my sincere gratitude for giving me this opportunity. In my speech today, I'd like to touch on 3 subjects on Japan's AI strategy. Firstly, I'd like to give you the background why Japan put emphasis on AI principles and ethics. Then I'll share with you an overview of Japan's AI strategy, which was established last year. And lastly, I'd like to express my views on the important pillar of Japan's AI strategy. This is to say, the construction of a core research network of AI. So please recall the first subject, why Japan emphasizes on AI principles and ethics. Nowadays, AI and utilization of big data are changing our lifestyle at an accelerated pace. AI has brought us advanced medical diagnoses, automated driving system, high productivity in manufacturing, and so on. On the other hand, the rapid expansion of AI utilization arouses public concerns over cybersecurity, invasion of privacy, and the possible loss of jobs, as symbolized by the word of singularity. In this respect, what is the key to realize an AI-ready society in which people can enjoy the benefit of AI while relieving the concerns. The answer is the social principle and ethics. This is why Japan formulated the social principles of human ethics AI prior to examining its AI strategy. The social principles of human-centric AI upholds the three basic philosophies of dignity, diversity and inclusion, and sustainability. It also consists of 7 strategic objectives in light of education, fairness, privacy, security, and so on. Furthermore, in order to make it a common global vision, Japan contributes to establish the G20 AI principles as the chair country of the G20 Osaka Summit last year. Now, I move on to the next subject, an overview of Japan's AI strategy, which was established last year. Japan's AI strategy was set 4 strategic objectives. 1. Human resources. 2. Development to real world. 3. Technologies for inclusion. And lastly, international cooperation. It also identifies initiatives for building a foundation for the future, including innovation environment, infrastructure for industry and society, ethical, legal, and social issues to achieve the strategic objectives. As I noted earlier, as the third subject, the construction of a core research network is one of the important pillars of Japan's AI strategy as the initiative for innovation environment. In order to further enhance Japan's AI-related research capabilities and promote social implementation of research results, it is important that universities and public research institutes must cooperate and complement each other while exhibiting their respective strengths. Under such recognition, Japan established AI Japan R&D network last year. 109 organizations, including 80 universities, are actively engaged in AI R&D in Japan. In response to the current situation about the COVID-19 infection, AI has contributed in various aspects such as therapeutic drug development, PCR, infection simulation, and remote environment treatment. I believe that AI Japan R&D network will contribute more to providing opportunities for collaboration of AI research and development in Japan. As you may know, the European Commission and Japan signed a letter of intent on strengthening cooperation in science, technology, and innovation on 26 May. I hope that we'll continue to work closely together to promote the successful development and deployment of AI. Lastly, I'd like to express my heartfelt and deepest appreciation of Ambassador Martin Tomko and their staff for organizing this webinar. Thank you so much for your attention. Thank you.
Now, I would like to introduce first of the speakers, first of the presenters, Dr. Tomáš Mikolov, who used to work as a researcher in the United States in Google and Facebook, and currently he is building a new research team at the Czech Institute of Informatics, Robotics and Cybernetics in Prague, with focus on complex systems and general artificial intelligence.
It will be about the contribution of the Czech Republic to the deep learning research, which is actually the part of artificial intelligence that made the most progress recently in let's say, the last decade, if you did read all these news about how AI is solving some new amazing tasks, then I would say more than 90% of this was actually based on the techniques that are being called deep learning, which is actually itself like a form of artificial neural networks, which goes back to at least the 80s from the previous century, when these ideas were mostly developed. At the same time, you may be wondering how comes that this AI boom didn't happen already in the 80s, but why did it take another like 20, 30 years? Well, the thing is that just having the ideas is not enough. You have to actually make them work in some important tasks. And while you are trying to do so, you have to develop a lot of small tricks that are actually very important and that are not that easy to find. So it took many researchers, actually several decades, to get to the point where the deep learning started to actually work. And today I will be talking about the contribution of several researchers from Czech Republic who did actually contribute to this breakthrough discoveries that actually happened that 10, 15 years ago. So the first thing that I did actually see as a student was this work of my more senior colleagues who were using multi-layer perceptrons, which is actually what is today called deep learning, in a speech recognition system. It used to be just this small box. If you actually look at it, the whole speech recognition system used to be like very complicated, and the neural network was kind of like smallish, but it already had all the important components that today are used in deep learning. That is, it had several nonlinearities. It also did work very well. It was able to reduce the word rate by about 10% over like a very strong speech recognition system. And actually, František Grezl, who did produce this work, did publish several papers around it. He was not alone actually in the Brno speech recognition group. There was also like Petr Schwarz, who did create a phoneme recognizer that was based purely on neural networks, and there was at its time like a very amazing work that actually did convince at least part of the speech recognition community that there's actually some hope that these neural networks can work, even if at the time there was a lot of disbelief. And it actually follow in similar lines, but actually I was interested more in modeling the language, because that's an important part of speech recognition, as well as machine translation and many other tasks. So for me, it was personally more interesting to work on language modeling. But when I was a student myself, there was like this kind of like a not very exciting atmosphere in the language modeling community, which was very smallish. People actually believed that there's not really much any gains left to be achieved, that if you actually use large Angular models trained on a lot of data, that they are going to be unbeatable. That was basically the atmosphere like some 15 years ago. So here we can even see the graph of the progress of the best results published in language modeling on some standard benchmark. And you can actually see that the gains over time were getting smaller and smaller, and were actually more like suggesting that we are reaching some plateau and that there's not really much anything more to gain. When I actually joined this research direction, I did believe actually that there's quite a few more things to be done, that we can actually do much better, even if basically several generations of researchers before me didn't actually advance significantly the core ideas behind language modeling, which was based on this Ngram statistics going back to the middle of the previous century to Claude Shannon, who was already applying them these models to English. That was actually the famous scientist who did win the Nobel Prize for the theory of information. So there was really not that much more progress in terms of ideas over maybe half a century. However, when I joined this research direction, I did really believe, for a couple of reasons that I'm not going to discuss in detail, that neural networks can actually work quite a bit better than the state of the art. And this is actually the simple model that I more or less started with. And it's basically a neural network with just one hidden layer, but it has the specialty that it is a recurrent layer, which means that it can create short-term memory.
I'm really sorry. Could you share your slides again, please?
Oh, okay. So here is just like a graphical representation of the recurrent language model that I invented around the year 2010. Actually, it's based on ideas going back to Jeff Ellman from the 1990, but it's having quite a few differences in how the model is trained. I'm not going to go over all the details, but just to explain what was actually the magical thing. The whole model can be described by these few equations. Maybe they look a bit complicated if you see them at first, but if you would actually see other types of language models, then this is actually a super simple approach. Like you can really code all this model in a few lines in C++. So it's very simple. And again, actually, there was a lot of people who did believe that this model is way too simple to actually work well. There was this impression that we have to do something very complicated, but it turned out that actually simple things work amazing. And if you actually look at what happened actually after, there was this progress in the quality of the language models where actually lower is better. And you see that over the years, I did publish a couple of papers that were actually incrementally improving my original paper on these recurrent language models. And the perplexity dropped by a huge margin. And it was actually amazing to live during this time because it was kind of like a revolution. I did go from like a point where most of the researchers, almost all of the researchers in the community were thinking that these models cannot work ever, to the point where actually everybody was using them. It took maybe just 2 or 3 years. So it was really amazing to see this, and actually you can see that even the further state-of-the-art results on language modeling, everything is today based on neural networks. So it completely took over and changed the direction in how people think about language. So I just have like these few slides that just show that it was very difficult to actually work on language modeling and neural networks before actually there were like these huge gains, but after actually we discovered these breakthrough technologies. There was this deep learning boom where actually large majority of the research communities in the natural language processing, the speech recognition, and machine translation, they all started to use these multi-layer neural networks. In other words, deep learning, and suddenly it was exciting to see this. I will also speak about one final algorithm that is used as a building block in pretty much like many NLP applications, like natural language processing applications. It can train distributed representations of words extremely fast. I did publish it when I was working at Google Brain in California, but actually it's based on the ideas that I developed originally in Czech, so I'm including it still in this presentation, and it's one of the most cited papers ever published in the area of natural language processing. So again, like the models can be shown like their graphical representations is extremely simple. Instead of a language model where the task is to predict the next word in a sentence, these models are using sort of like a back of words representations to predict the middle word in a sentence given a context. There are some differences, but I'm not gonna go over the details. Thing is that when we trained these models on like 1,000 times more data than whatever could do before with the previous techniques that were having the same objective, we did obtain these numerical representations of words. In other words, the word vectors, is where the name comes from, that had such a high quality that when we did visualize this space, we could see the structure of the words in this 2D map. So each word is basically converted to some sequence of numbers. That's the vector. And then we did do this visualization. The gray arrows are added supervisedly by us. We basically did observe that there's some shift in this space where we go from a country to its capital city. And it was all trained by a model that just basically reads the Wikipedia and nobody tells it anything. So it was actually quite amazing, and it convinced many of the researchers that these models actually can be extremely powerful. And actually that's what happened. These models became especially the neural language models became part of Google Translate. That's basically why there was this huge improvement in quality that you may have observed a couple of years ago. I was at the beginning of this project. I started a collaboration between Google Brain and and Google Translate teams. So it's really used in tons of applications, including Google Search, and basically many of the applications that you can see today on the web, they are using some form of either war vectors or neural network language models somewhere hidden in them. So I would say that the breakthrough technologies that allow this to be developed were actually developed in significant part here in Czech Republic. We did also like open source these projects. So I think that we did great on the basic research. At the same time, I think that we could have done a little bit better when it comes to connecting the basic research with the applied research and industry, because if you really see where these models that actually generated the biggest profits, it's actually not really Europe, it's in the US, where actually today is the United States are today the center of the AI research, which I find a bit unsatisfactory, but that's basically the reality, and we have still a lot to improve in the future. So I think that we can do great research here in Europe, here in Czech Republic, but I think that we can be doing better in the future when it comes to also generating the applications and the profits here back in Europe. So that's all from me. Thank you for the attention, and just I have a couple of references if any one of you actually wants to see these almost historical papers by now, even if they are not that old. But as I said, they were at the beginning of this deep learning revolution, and we can go to the details in the question answering session at the end. Thanks for the attention.
Thank you very much, Dr. Mikolov, for your presentation. I hope that we will have a chance to hear from you more at the very end of the Q&A session, and hopefully also to see you. It is a shame that we can't see you. Anyway, the next presenter is Dr. Peter Galambos, who is the director of the Antal Beici Center for Intelligent Robotics of Óbuda University in Budapest. His research includes advanced artificial intelligence for industrial robotics and control systems, cyber-physical systems, and virtual reality. Dr. Galambos, floor is yours.
Okay, hopefully everyone hear me now. Is that okay? Fantastic. So thank you very much for the introduction. It is my great honor to make this talk here in this important event. I would like to talk about the advanced AI for industrial robotics in an aspect that we are representing here in Hungary, in some sense in close connection to our partners in Visegrad countries, and in close connection with our Japanese partners. So let me very briefly introduce our institution. Our name giver professor is Tony Beici, who was probably the most well-known roboticist, originally born in Hungary. But actually his research activity was performed in the NASA JPL, and we are very proud of using his name as a name giver of our laboratory at Óbuda University. In robotics, because robotics is a very huge research and application areas, we cannot deal with everything. We are focusing on telepresence, advanced applied robotics, cloud robotics, and medical robot applications, which we usually refer to as industrial and medical cyber physical systems. Here are some of our major topics, what we have real experience: robotic system design, manufacturing, control design and control science, machine learning and other AI techniques, prototyping, mechanical design, and proof of concept validations of not only AI-based solutions, but any sort of modern technology solutions in the mentioned topics. Our other leg in robotics is the medical robot applications, in which we are focusing on surgical robotics, including skill assessment, surgical ontologies, and other semantic representations used in minimal invasive robotic surgery. Our mission can be characterized with the sentence end-to-end innovation model, which means that we go in research from the formula to the prototype. So our goal is to cover a very wide spectrum of the innovation value chain. Therefore, in our groups, we have people who are performing fundamental research in physics and mathematics, and also we have very practical people, engineers and technicians who can transfer the theoretical research results into prototypes. I just included a bunch of pictures from the Robotics Center of Óbuda University. We are dealing with various robotic arms and other devices. As you see, we often make introductory lectures to secondary school and even for primary school students about robotics. We do have a makerspace, which is very common actually in Japanese universities. So in the research lab, we can create our prototypes on our own premises, which is very cool. And you can see that, for example, in this April, just before the pandemic, we hosted a group of students from the Shibaura Institute of Technology from Japan. They were enjoyed pretty much their internship in Hungary. Let me just introduce the lab in a VR modality. So you can see how we built up the robotics lab. This is an area where industrial robotics research is performed. We have a surgical robot system with a research controller, and we can jump over here to the makerspace. It's a little bit messy, but it is very active. Many students and engineers working there. We can come back later on. We try to be active in V4 countries in different partnerships. We have just finished last year a successful project with Czechish and Slovak universities together, and just yesterday we submitted a Horizon 2020 proposal dealing with flexible worker-centric robotics in the food processing industry, and the key partner here is the Czech Technical University at Prague. Professor Václav Hlaváč is the main scientific contributor to this proposal, and hopefully we can establish a really fruitful connection. Not only in the V4 countries we are active, but it's a long tradition in Óbuda University to make good friendship and deep friendship with Japanese partners. Therefore, we have active connections to the Tokyo Metropolitan University, the Tohoku University, Nagoya University, especially a very active student exchange project with the Shibaura Institute of Technology. And for example, one of my students is now on a Vulcanos internship program at Omron's robotics group. And we are very proud of our Japanese advisory board members. Those very recognized professors are considered as just superheroes of robotics from Japan. Toshio Fukuda is actually the current president of IEEE, while Kazuhiro Kosuge, professor, is the president of the Robotics and Automation Society of IEEE. Robotics is a disruptive megatrend today, and it is very hard to talk about pure robotics. A few years ago, let's say in the early 2000s, robotics was a quite clear discipline. But now robotics is overlapped with Internet of Things, drones, 3D printing, artificial intelligence, virtual reality, etc. And it became a really huge business, and it has a great business potential. Therefore, we are thinking in robotics and artificial intelligence as an umbrella topic. And actually, it's a very important and very huge meeting between the well-established AI technologies. Just we have heard from Dr. Mikolov in the natural language processing topics. These techniques are now in connection with advanced mechatronics, and this will be a really huge impact to our everyday life. And our research topics would like to contribute to this fantastic revolution. There are some really hard challenges in robotics, not mentioning here the language-related cognitive parts. I'm here rather focusing on the motion and action related topics, which are also very common and means today a technology barrier in front of the robotics development. In that sense, the robot perception, the knowledge adaptation, various kind of motion planning of mobile robots, the whole body structures, and the precise fine motoric manipulations are included in the most challenging questions. And many of the current research activities all over the world aimed at formulating the general knowledge in a way that is able to synthesize useful robotic actions in a highly autonomous manner. Another important topic now is the cloud robotics. You may know that every robots are restricted in terms of CPU, memory, electric power, etc. Therefore, most of the computational elements, the computational agents, are usually transferred to a computing capacity outside of the robot. This phenomena is the so-called cloud robotics or cloud sourcing, in which the brain, the intellectual capacities of the robot moves out to the cloud. We can see the two ends of this spectrum, the conventional robotics in which everything is included in the robot controller, and the other end of the spectrum in which the robots are basically just puppets without onboard intelligence. Only the sensing, actuation, and communication is on board. And this approach opens a really huge opportunity for AI-based robot applications. In Óbuda University, we are involved, for example, in industrial intralogistics research for developing AGVs, autonomously guided vehicles. And our task includes sensor fusion, cruise control, simultaneous localization and mapping, and for example, obstacle detection, which is a very good field for visual AI techniques. Here we have serious challenges, what we have to solve with very simple onboard sensors. And to show some results, I included a video here where we can see. Hopefully, I can play the video. Yeah. Where we can see how the so-called optical flow modality can be used to detect moving obstacles on board of an industrial intralogistic mobile platform. These is performed through convolutional neural networks that was mentioned before in the presentation of Dr. Mikolov also. These techniques are now available, just can be included in industrial products, but the technology transfer is always a huge challenge. Another very interesting topic is the sensor fusion, in which from different sensor modalities, higher level and more precise information can be generated. And many AI techniques from the machine learning, for example, principal component analysis, and also deep learning can be very useful in tuning of sensor fusion solutions. Inside solutions, the mobile robots, for example, can be equipped with arbitrary kind of sensors, and an AI-based predictive model can compose the optimal or suboptimal construction of a sensor fusion computational model. A very practical AI-based solution is the so-called bean picking or assorted manipulation in industrial robotics, where the robots can cope with unstructured environment, for example, mechanical parts or that are just in a heap from which the robot need to grab and place the parts to an assembly, for example, and making this fast enough and robust enough is still a challenge, but there are some really good results and really good commercial applications, partly from, for example, Slovakia, from Japan, and also from Hungary from our laboratories. We are kind of active in this field. I could show many interesting videos how we teach the artificial intelligence through simulations, but I'm just running out of time, so maybe we keep the rest for the question and answer session. Feel free to compose your questions and deliver those to me. In the end of today's event, we have the chance to talk about all the results and possible contributions, possible cooperations between V4 and Japanese researchers and business-oriented people as well. So thank you very much for the attention.
Thank you very much, Dr. Galambos, for your interesting presentation. And from Warsaw will now be joining us Mr. Robert Kroplewski, Plenipotentiary of the Minister of Digital Affairs of the Republic of Poland for the Information Society. The main topic of his presentation is the transborder ecosystem for sharing data and artificial intelligence development. Mr. Kroplewski.
Good morning, everybody. One more time. Thank you for invitation for Czech representation in Tokyo embassy, and colleagues from Japan and colleagues from the other Visegrad countries. I try to say some words from the policy making perspective, not so much about the developing and science, but is also included. I try to present the shaping trusted transborder ecosystem of sharing data and artificial intelligence development from Polish artificial intelligence policy perspective. It is very good that we meet together with that composition, five countries, 4 from the Central Europe and 1 from the very far away Asia, but very modern and like-minded thinking in many topics. Some words about Poland and our efforts and our attitudes from the history and now to present our country and our Polish scientists. Our colleagues are co-authors very famous and internationally recognized projects. For example, OpenAI, PyTorch, FastTech, Bio, Inception, and AlphaStar. And last very good industry which is developed in Poland is gaming. You probably know the movie Witcher produced by CD Projekt. But why we do it? Because we have a good basement. The basement comes from the Mr. Stanisław Lem, the author of Reality of Futurism, internationally recognized prophet of new technology. Many things, probably everyone recognized by him during the 70s and 80s. Now it's a reality in the global virtual space. But also we have a historical backgrounds. We had a Polish School of Mathematics. They produced Enigma and was a cooperator with Turing Institute. And now we have a very good youth which gets the 4th position in the PISA index rating of OECD. I try to say this because we have a big background and we carry our work globally. Try to do it. Of course, we have a problem because we have a big immigration, scientist immigration, and our main topic now is to invite our colleagues, our engineer, to work with Poland with special institute which we launch in some months. Our strength side now. Our GDP is depending of 46% of flowing of data. This is a strength of agile governance. If we try to, our strength is depending of 46% of flowing of data. Also, our society represents 36% of creativity class. We are very deep in the special projects, very modern, human eye, brain eye, Casus also. And scientists represent, academia represents bio and social knowledge as an input of artificial intelligence actually. We launched the Foundation of Future Industry, special central institution which governs our transformation of industry for zero artificial intelligence, Internet of Things, and blockchain also. I mentioned the Łukasiewicz network. This is a first virtual institute of scientists engaging microelectronics, automation, logistics, artificial intelligence, and marine and cosmo industry also. But from the cybersecurity perspective, we have a national public institute called NASK. That institute, we agree in our policy to create the standards of robust AI and cybersecurity in artificial intelligence. A very short picture of our policy, artificial intelligence policy. We decided not to take part in the global ranking as a priority. We decided to build the ecosystem from down to top and from top to down. And if you could see, one of our feature is the international dimensions. If I could say something about this, we of course are open for like-minded allies, but also has a priority. We have a priority of legal perspective. For example, no personal, no personalization and no legal personality of artificial intelligence is our priority. Also, this balancing of the platformization, and finally, we are focused on the flowing of data, not only in the European Union, but also outside of the European Union. But we try to, we discovered that our problem is of coordination of our assets. We have a good scientists, we have a data, we have a business and clients, we have even infrastructure, but the coordination is a key thing. And because of that, we decided to launch the governance of artificial intelligence. The leader of that governance is the Ministry of Digital Affairs, with special community of digitalization. We are oriented or ethical artificial intelligence, but from the human dignity perspective and well-being of society. And we approve and we support the European concept of trustworthy of artificial intelligence. That concept is also a part of the stewardship of artificial intelligence project called and published by OECD. But coming to the global things, that is a big question. Whose system governs artificial intelligence and global order by artificial intelligence? And we even decided that no one but rules of the market and the technology decide who is the first. But having many organizations from one side, from the multilateralism like OECD, European Council, Council of Europe, UNESCO, and World Trade Organization even, we couldn't find any special governance of artificial intelligence. We, from the Polish perspective, rather try to find and feel that is a chance that we can create some pluralism of other fora. For example, Visegrad countries and Japan or other like-minded countries to create some governing of basement or enables of artificial intelligence and artificial intelligence itself. This is important to say that Japan and European Union has a free trade agreement, but that agreement is very poor. For example, Visegrad countries, Czech Republic, Slovakia, Poland, and Hungary were very active partners to promote the very offensive free trade agreement with Japan, focusing on the free flow of data. Unfortunately, the European Union, because we are part of this, decided that only the revision clause is enough in that agreement, and we will wait how it works, how the future will be, and maybe we come back to the more ambitious clause on flowing of data. But it's very important to say that no rules of digital trade is produced by a World Trade Organization. It's only moratorium on the duty on digital service. We have a freedom of flowing of non-personal data, fortunately, and it is not depending on personal data so much, and we have a space to create some good shape of sharing of data. This is important also to say that thinking and having the big picture, the data localization requirements exist in China, Russia, India, Brazil. Also, this is a problematic if you think about the open innovation framework of artificial intelligence. And we have a global competition on types of network, finally, and the first position on the market and on the governance of access to data pools. This is a problem, but at the same moment, this is a chance to create something original. Of course, we have a global competition on ethics. It's not about ethics like a high-level thinking, philosophical thinking, but also it is a main thing on standards, ethical standards. Now we have not only competition about interoperability or technical standards, but also about thinking how we can trust to artificial intelligence. We have three frameworks. One from the United States is very usable. One from the Asia, rather promoting by China, it's inclusion of people, and the concept from European Union and other countries like Visegrad countries. It's a trustworthy artificial intelligence, like a trademark and like a non-technical and technical composition of artificial intelligence. And no global stewardship of artificial intelligence development and deployment now. How to do it? And I'm happy that that meeting is organized because we have a chance to understand and maybe to create a common cooperation and understanding among stakeholders. But how? More productive way, it's not to establish a legal framework, but try to think about new RegTech deploy environment, soft architecture. I know that Japan is known from the Industry 5.0, and I know that Japan is known from the concept Society 5.0. It's very influential. Maybe we need to understand that concept more to try to find some solutions and cooperate together. But we have many problems in front of us. Before that, we have, of course, the chance, because the virtualization, if meets augmentation of the physical world and culture, we can find the new neighbors, despite of any borders. The virtual space is open. We can cooperate even with country which is situated with long distance. Japan is a very good sample of that. But of course, if we think about risk, the problem from the Polish perspective is the transfer of values and transfer of taxation. This is a topic, of course, which is now subject of OECD. But the future belongs to the new entertainment, and because of that, we, with our society, trying to be prepared for new dopamine entertainment, new dopamine economy. It's very risky, and the brain and autonomy of people, it's under the pressure, of course. But coming deep into the artificial intelligence concept, we have a crossroads. And in Poland, we believe that not so much computing power is important, but the people and know how to modulate the data and to keep talents in our country. Finally, that will be the feature, the big assets, like a main enabler, small data and people. We try to create our ecosystem focusing on people and keeping the knowledge with our partners inside of Poland. Coming to the topic about data and cross-border of data policy versus intellectual property protection, we try to find the solution in the raw data, because data is only a copy of information, but it's not subject of any ownership of data. The subject of ownership is the trade secrets coming, the information coming from the industry. Also, giving me this. This is important because data utilization intensity in Europe, it's presented on the topic, and Slovakia, Poland, and Hungary, and even Czech Republic has a very even the same level. But it's worth to say that we decompose the productivity, total factor productivity, and try to produce the data-driven productivity, and finally try to find how the biggest country find the barriers of utilization of flowing of data. This is the 18 and 25% of this. This is a problem of about big countries like German and that. The time is going, and I asked about concluding, but maybe I go to the main topic which I produced for today. This is our proposition for Japan. Try to launch special trusted space of sharing of data with methodology of decentralization, storage of data, cyber safe, mutual recognition of standards of API, blockchain, and special logic of rooms of trust from raw data in trusted cloud, but with respect of trade secrets and IP. This is very possible in the sector like industry, logistic, farming, health, and finance. We believe in this. I know that Japan is a promoter of data space globally, and from the Polish perspective, we accept that way. Thank you very much for attention. I wait for questions and answers. Thank you very much once more.
Thank you very much, Mr. Kroplewski, for this interesting presentation and very interesting initiative. Hopefully, it will be able to develop in the near future. The last, but definitely not the least of our experts is Professor Maria Bielikova, who is one of the founders and current chair of the Slovak Research Center for Artificial Intelligence called Slovak.ai. She is active mainly in research in modeling of human-machine interactions and personalization. Professor Bielikova, please.
So hopefully everything is all right. You can hear me and you can see my presentation. So thank you very much for inviting me, and thank you even a lot more for providing this event, because I, similarly as my previous speaker, I believe that Visegrad group is very strong, and not just Visegrad group. I think that we are more countries in Central Europe who can collaborate with Japan and other countries. Just first to tell you a bit about Slovakia, because we are a very small country, as you can see, just 5.5 million population. But what is important, we have very bright people here, and not just in Slovakia. Here is a skill value rank, IT ranking of countries worldwide, and you can see that from 2019, Slovakia is the best, but second, third, and fourth are Visegrad countries. So we have very good tradition in this, and very bright people. Unfortunately, but maybe fortunately, some of them and many of them are abroad, and hopefully we will be able to set up a process, if not just coming out, but coming in back to the country, similarly as Thomas. But I believe that the worth and the worth of country is really in people, and we should share them across the world, and then develop it. AI is a good tool for it. I really see it as a tool, not as something which will save us, as somebody tell, or something which is destroy us. In Slovakia, we started with AI some 50 years ago, with first AI paper published, and last year we started to closer cooperation across all sectors, academic, private, and government. In time between, there were a lot of collaborations, but still they were just local, just one-to-one in most cases. But Slovakia, a small country, needs one reference point, a center, and then a network of not just people but organization. And I believe that the similar model can be applied to Europe, and Europe already started with it, setting up networks of excellence in AI, because we have a lot of countries, a lot of languages, a lot of cultures here. What is important in Slovakia, the actual state which I would like to present you today, is that in 2018, there was set up a strategy of the digital transformation of Slovakia, and based on this, in 2019, from the bottom to up, a recommendation on AI development for Slovakia were created. So probably we took the different way as it was in other countries. So it wasn't initiated by the government, but community started to group, and they created recommendation, and they were finally accepted by government, and they were included in action plan for the digital transformation of Slovakia. We make two surveys, one on academy and one on private sector, and I will show you very briefly the results, and then you will see the shape of AI in Slovakia. One more comment on this is that on first we concentrate on deployment of AI. So to have as much companies to at least use AI and be AI positive. So it was developed a manual for companies to implement AI, but what is the most important is, of course, research, and I will speak about this most time of in my talk. This bottom-up approach came from Slovak AI, which was informally started in 2018, but formally in 2019 as a platform for excellence in AI and platform bringing together students, researchers, entrepreneurs, teachers, investors, and so on. So we were able to put all together. So at this moment, we have 59 institutional members, including 3 funders, which are IT Association, American Chamber, and Slovak University of Technology. Speaking about the academic institution with AI research, we have in Slovakia 7 centers for it. 2 are in Slovak Academy of Science, and then universities, which includes about 200 researchers in 27 research labs. What is important is to see which topics they are interested on. So mainly data analysis, machine learning, natural language processing, computer vision, speech processing, computational biology, knowledge representation, and AI in robotics is very strong, similarly to computer vision. Now I will very briefly came through several success stories of several labs, so it will be really brief, but you can come to this later, because now I will present some pages from success stories from this brochure. Just, I think what is important is to see the keywords, what researchers in Slovakia are doing. So there is group on transportation systems, human cognition, knowledge representation and reasoning, unified communication, collaboration platform for enterprises, and some more projects with Slovak Academy of Sciences. They have quite a lot of international projects. There is a strong group for natural language processing, which is collaboration of Slovak Academy of Sciences and Technical University of Košice. Slovak University of Technology is very strong in robotics. There is a group of Professor Duchoň with his a lot of international activities interconnected with Czech Republic, Hungary, and other countries. biometrics, multimedia processing, medicine, with collaboration with companies, for example, this one with Siemens Healthcare. Natural language processing group is working on false information and antisocial behavior on the web, so detecting and this solving this important problem. User modeling for e-commerce and e-learning. This is my group with quite a lot of industry collaboration. Smart grid. Professor Sinčák is very active in international community. Probably quite few people in Japan know him because he has strong collaboration with Japan and spend there some time. Data science, natural language processing, speech, cyber physical systems, perception, logistic. So this now you can have some picture on what are researchers in AI doing, but I now try to connect it with industry. So I've selected several projects from industry where companies are active in developing AI. I believe that it's important to connect all sectors, connect people, to know cultures. I've never been in Japan, but I tried it last Saturday with ramen soup. So this was good inspiration for collecting all this to present you and to look forward to collaboration. We did a survey in private companies. 247 companies were included in this survey, and you can see that more than half are AI positive. That means that they at least have some AI already on board, or they think in a very short term to have it. The most intensive AI application domain, according this survey, was finance domain, but you can see that there are more with very small differences. So these are the domains in which Slovakia at this moment has the most results. Actually, to be honest, I have to say that we don't have set priorities by our government yet. So we still not just wait, but we believe that our government will be able to put one or two for Slovakia and to try to develop it similarly as it is already done in Czech Republic. As I know, they concentrate quite a lot to safety and security. This picture shows what respondents in this survey think about future. So which domains they think that they will develop, and they are useful develop for Slovakia. There is a pretty much with previous figure. I have to tell that not just solutions that will advance and innovate our processes, products and services, but we support European approach to trustworthy AI, and you can see here that most of companies really support it. We have a very active group of researchers from humanities and social sciences, philosophers, psychologists who are really active. And our government is just about establishing ethics board on the level of government. Here there is 10 examples, similarly as I gave you examples of academic research. Some of them are in collaboration with academy, but most of them are at this moment just results provided by industry and private sector. I will go very quickly through it just for you to see the companies, to see the keywords, what are they doing, and how they use AI for, and then you can later on to go back to this. So you can see some work on chatbot and natural language processing, which is very important for Slovakia. We are a small country and nobody will work on Slovak language except some from Google, but this is quite a high priority. Actually, my student, doctoral student in 2013, when Thomas language model came in his paper, started to work on it as well, and I can support what he has told, that at that time nobody believed, and we had really problem to persuade colleagues to really accept this, that this is good way to do research in this domain. There is another company with chatbot, Smart Industry Solution. There is a nice solution for onboarding AI in maintenance, manufacturing, image analyzers, sentiment analysis. This is collaboration with Slovak University of Technology. Most of the companies are not just Slovak companies. They run based in Slovakia because we are a very small country. Similarly, as Expona product, maybe it's known more on US identification of new customers, data processing for energy, and we have quite well-known company in gaming, and they use AI as well. So just to conclude my presentation, I would like to stress one more. Then we follow approach European Commission started with trustworthy AI, and we really believe, and I believe that there are needed some regulation, and we need them worldwide, because in other case we can come to situation in which AI. I don't think that general AI is really very close to us, but still there is danger in, for example, people monitoring and so on. But I don't think that we should put so much effort just on negative risk, because there is also risk that we will not use potential of AI. So this is a strong industry position. Recently, there was reaction on a lot of reactions on white paper on AI, European Commission received some 1,000 and more responses. We will see how they will be, but there was at least one from Central and East Europe, which was very strong in this positive use and risk of AI. What we need in Slovakia is to go from this platform level to the level of National Institute in Slovakia, which will be reference partner for everyone. And this is my last slide, and thank you. I believe that whole Central Europe is interesting. You can see Slovakia is here, the almost smallest one, but with very bright people. Thank you.
Which question was it?
I didn't hear it. Yeah, about the Czech-speaking AI, which would support elderly people.
I did just answer it right now. So I know that actually Jan Šedivý here at CERC is working with his team on chatbots that would be helping, for example, people which are having some mental issues, like, for example, the diseases of the type like Alzheimer. So he's trying to develop communication agents that will be helping these people to communicate frequently, to use their memory, so that it will be kind of like a mental training for them, so they can stay healthy for longer. So I know, for example, about this example, which is actually being performed here in Czech.
Thank you very much. That's the first question. The second question is to Mr. Kroplevsky. And the question is why the AI is not to use to identify the obsolete or not the efficient legislation and international trade agreements mentioned in your presentation.
Excuse me. Thank you for that question. This is an important question from the high-level perspective. Trying to answer why. It is a problem, of course, coming from the old legal framework of treaties, international treaties, but also about the protectionism of status quo old community. It was changed 4 years ago. Community focus in the OECD tried to rebuild that picture and decided to create the agenda of digital transformation, even the members of the OECD. The project is called Going Digital, and because of that project we can observe now how the policy around the world of digital transformation is shaping by the countries and actors. And artificial intelligence, unfortunately, it's too young to be seen by treaties. But of course, we don't need to see this. It is enough because the free of market to cooperate and establish own rules like a good samples, good code of conduct. This is I try to answer of this. Thank you. And maybe one more thing. If we are on the World Trade Organization Forum, this is a big question. What is more important, old industry, agriculture, or new technology? And till now, maybe it's a little better, but till now the agenda or digital agenda is still before the door. It's like even slave of old industries. Thank you.
Thank you very much. We have a question to Dr. Galambos, and the question is that if you could tell us the cloud robotics application example and bottleneck of a slow connection.
Yeah, thank you for the question. So in cloud robotics architecture, it is very important what can be put in the cloud and what cannot be or what should not be. There are real-time requirements in several robot applications. That means, for example, safety-related functionalities cannot be cloud sourced easily. But for example, user interface functionalities like chatbot functionality, natural language processing functionalities, or some visual recognition, visual perception that are not related to real-time safety critical functions can be easily moved into the cloud. Current standards not really discuss such distinction between safety and non-safety related functionalities, but the risk assessment that is always necessary and required before deploying and commissioning any robot applications must handle this question. And although cloud robotics has different approaches, for example, in an industrial company, there can be on-premise virtualization of computing capacities, which means the network distance between the application and the server is not so long. Everything is practically in a local network infrastructure. On the other extremum is when the cloud-sourced computational capacities are in a public clouds in Google, Microsoft, Amazon, etc. When the availability is more critical and must be always handled properly. In our practice, we deploy on-premises solutions where the host organization, the manufacturing company, can guarantee the availability of the virtualized services to the robotic solution. I hope I answered your question.
Thank you very much. You sure did. Question to Professor Bielikova. What is for you more important, the artificial or human intelligence?
Thank you. It's really a tricky question, but for me personally, I always will prefer human intelligence because just human create machines. Human brain is a system which really needs not so much energy as our machines need, and but to live well, we need machine intelligence, as we can call it in this way. One day maybe there will be general artificial intelligence. I don't think that it's so important to know it, whether it will be or whether it won't be. The more important is to try to use the machines as much as possible to serve humans and to have educated humans to have intelligence. So I believe to educations and not just education in AI as we are speaking about AI, but having educated people, they then will be able to save our planet. In other ways, there can be some not very nice scenarios, I think.
Thank you very much. It is definitely a tricky question, so I would like maybe to ask another presenters if someone wants to add something interesting to this. Okay, Mr. Kroplewski.
Thank you very much to join me to add something, because I accept and support everything what Maria said. Education is a key. We need to not so much educate people in the digital skills, but more on creativity, open-minding, and the working together. The collaboration is the future between people, especially if we can find the artificial intelligence like a machine, like a networks of the artificial intelligence systems. But in the same moment, I believe in this, that we need to develop ourselves like a human intelligence and machine also, because machines has other features. For example, speedity, yes, but we have a unlogic consciousness. We are very creative like a people if we are, but we can use the strength side of artificial intelligence to educate people and to help our everyday life. This is that. But thinking about the general artificial intelligence, personally, I'm not optimistic that we can find that kind of machine. Why? And maybe answer it's on that level, because our Polish philosopher Włodzimierz Sedlak in 70s said that quantity of data will not create a consciousness. This is that, because the consciousness, it's a more complicated, more complex way. If it will be like that, we are rather safe. But it's a second feature also. To create the general intelligence, we need to establish, to build, but before develop the not determinate architecture of that kind of brain. This is big challenge for now. We don't have that knowledge. Artificial intelligence still is not so intelligent. It's a quiet. Thank you.
Thank you very much. I guess this was very exhaustive response. Maybe one final question for Dr. Mikolov. And the question is, we see how people think about language, but how AI thinks about language. Do you think AI is considering human language as needed, or would it become eventually obsolete?
Thanks for the question. I still see a couple of more of them, so I would try to answer this one quickly. And I think there's actually one very interesting question that is later in the chat, which I hope that we can actually all address in the end. So first, your question: do you think that AI is considering human language as needed, or would it become obsolete? That's kind of like a strange question, because if you actually see how these like AI models work, basically you could see the language models equations that I was showing during my presentation. There's not really like any understanding at the moment. We have statistical models that learn regularities in the language, like from the point of view which words occur together. And that's actually the core of the state of the art today. There's no understanding. We don't even know how to create machine learning models that would have any sort of reasonable memory capabilities. You can actually see that the best chatbots today don't have any memory. You can just tell them some fact, ask about it next, in just the very next sentence, and they will totally fail. So today, we don't have any AI that understands language, which is like basically pattern matching. It's smart techniques, they can work well. If you have like millions of examples of pairs of sentences that get translated between languages, yes, you can train a statistical model that will work as a reasonable machine translation, but there's no understanding behind it. It's basically just pattern matching. So that's to answer this question, like we don't have any AI that would be considering human language obsolete, because we don't even have any AI that actually has any potential to understand the language at the moment. Of course, the researchers are working on this. It's a great scientific goal, but this question basically goes very much ahead of its time. So actually the question that I did think that we can actually end this session with, which I think is quite a tricky one, and that's why I actually think each of us can address this, is like, what is the reason why the EU countries cannot make a profit like the United States? And I think it's actually a quite important question, because we are discussing a lot here in Europe, and not just in Europe, how to make this AI ecosystem kind of like complete. But we should be not doing just the basic research, but we should be also like applying this research to some new products and selling these products. Should be kind of like a full circle. At the moment, the circle doesn't really exist here. It does exist in Silicon Valley. It does exist in the US. You have universities that produce students who go to companies that create novel products that get sold all over the world. But if you actually look at where actually are located at the moment the biggest kind of like AI companies, you have them all either in the US, you have few of them in China, but you have basically nothing in either European Union or Japan. So I think that's kind of like a difficult topic, and I think that's the one that we should be actually discussing if we want to improve the state of AI in Europe. Like where does the money go? How comes that we cannot keep the profits here? What should we do? So I think it would be great if all of us would try to give his opinions. I just basically did this introduction. So I guess the others can maybe try to answer it.
Dr. Galambos, do you have anything to add to this, please?
So these sort of questions that are challenging the maturity of artificial intelligence is always very interesting, and those questions are rather philosophical at this moment. I think, in my personal opinion, first of all, we should concentrate on the improvement of specialized AI solutions, both in for example, motion synthesis related, fine motoric skill related AI solutions, as well as the communication related and business analytics related AI solutions. Then implicitly, this process will improve the generic AI as well, and this sporadic situation in which different points in the spectrum is emerging. After a while, everything will be just mashed into one globally meaningful AI solution, which I think it will be some sort of mixture of very different approaches, not a single equation or a single structure. Yeah, that's my 50 cents.
Thank you. That was excellent. Mr. Kroplewski, do you have any final sentence to say, please?
My final sentence, wow. The discussion was very interesting. Thank you for any voice from my colleagues, presenters. Trying to saying something at the end. This is the key. Collaboration. We need to think from the big picture. We need to find the like-minded partners. Japan, it's, in my opinion, it's like this. We have our good attitudes and good strength side from the industry, from people. We have a creative people like Visegrad countries. We have a good situated countries from the geopolitical perspective, but the new virtual cooperation is needed for productivity of members that club and well-being of society. We are able, I think, to establish that kind of cooperation from the very concrete project perspective and from the high-level policy layer also. That was good to take a part with this conversation. Trying to only answer for people, because I see on the chat, is it any possibility to come back to the new treaties, Japan, European Union. After 2 years more, the European Union decided to start that discussion, but we can now find the very practical way how to cooperate with data, even don't waiting for the legal framework. It is a very big perspective. Thank you.
Thank you very much. Could I ask Professor Bielikova for her final comment?
Thank you. I firstly agree with all what was said, especially now by Robert. So I will not repeat it. I will go back to question which Thomas has taken about why Europe is maybe a kind of behind, even though, for example, research in AI in Europe is really strong and in many aspects stronger than in other countries. We have some history, for example, in this Central and Eastern Europe, this 40 years under communism. Actually, we cannot skip it in such short history. And people minds will need even at least 1 or 2 more generations. We have 30 years after it, but still I can see in even in young people some signs that are different as in, for example, US, and these people are in charge in government. So this is quite important that we need young generation, and we have it. So what is good in this sense that Europe, and especially this part of Europe, can be very attractive because people are really bright and hard working, so they used to work very hard. And I believe that in world we can maybe get success in a similar approach as AI did. You know, in classical AI, we had explicit knowledge represented and use them. And in now sub-symbolic artificial intelligence, when neural networks and deep learning are now very active, it consists of very much many small actions and interaction. We don't understand how it works really, why it works really. But it works, and I believe that we can learn from this, and we can do this on the world level. So making a lot of small collaboration and small centers, big centers, and then interconnect, and try to build such neural network within collaboration. And this maybe will move us and did a breakthrough, and then we will not recognize that this country is better, because the last sentence maybe you know, but now not countries have are the richest at world, but some companies are richer than many countries. So situation is now really changed. Thank you.
Thank you very much, all of you, for very interesting contributions. Ladies and gentlemen, I'm afraid that we exhausted the time, and we came to the end of today's agenda. Thank you all very much for your kind attention. We do hope that in spite of some minor imperfections, the webinar was interesting for you, and that it brought you some useful information and new ideas, and that it opened maybe some promising areas for the development of future cooperation between Japan and the Visegrad Group countries. I would like to very much thank the whole organizing team, all the supporting institutions, and above all, our 4 excellent presenters. Please stay in touch, stay safe, and have a nice day. Goodbye.
Goodbye. Pleasure.
Bye-bye. was nice pleasure.
Do zobaczenia.